Next is three schema architecture. The three schema architecture is a framework in database that is used to manage the data abstraction and separation. So basically, the schema can be in three different levels. First is the physical database or the internal schema. So you can define that as the internal schema. And next we have the conceptual schema. Then we have the end user view that is called the external schema. You can write this as view 1, view 2, and view 3. That can be accessed by various users, say user 1, user 2, and user 3. So we have physical database or the internal schema, conceptual schema, and the external schema. Internal schema or the physical database, the physical schema is nothing but it says how the data is stored physically in the database. Basically, it deals with the storage structure. This deals with the storage structure and how the data is stored in the database. Conceptual schema deals more with the logics. It says what kind of database entities you have, the relationships and the constraints. So, this is more or less like the logical structure. External schema or the view schema is nothing but for viewing. This schema defines that how different users are going to view. It gives you a different perspectives that how every different end user can view the data in different forms. This kind of mapping is important because we can maintain consistency and integrity of the data. Also, we can maintain the consistency in the data. Database management can be simpler. These are the few reasons why we do this kind of mapping, or these are the advantages of mapping it in a certain way. We can access the data in a more flexible and an independent form. We can have different user specific views. User specific views can be created. And data abstraction. So data abstraction is nothing but it allows you for separation of physical storage from the logical representation. So that is data abstraction. So data abstraction is a concept in which the physical data structure or how the data is stored is completely different. It is completely data abstraction is a concept where you can clearly highlight or show how the data is separated from the physical storage and from the logical representation. So it allows for the data abstraction separating the physical storage of the data from its logical representation. This separation ensures that changes to any physical structure does not impact the logical structure or the user schema. Next we have different types of attributes in a ER model. Different types of attributes in a ER diagram. What are the types of attributes we can have? We have first is simple attribute. A simple attribute is something that cannot be divided further. It cannot be divided into any further entity. Let's take an example of a student who has a roll number, name, and an ID. So these are some examples of a simple attribute like roll number that cannot be divided further. Next is composite attribute. A composite attribute is the one that can be further split. For example, for the same student, let's consider address. The address can further be divided into, say, the floor number, the street number, cross, area name, etc. So composite attributes are the ones that can be split into further several subcomponents. Next is a single valued attribute. Single value attributes are the one that can take up only a single value. For example, a student has age that can take up a single value, like a roll number. Next is multi-valued. Multi-valued is nothing but an attribute that can take up multiple values or more than one value. For example, a student, you can take an example of a phone number of a student. Let's consider a student, say, has a phone number. Now, this phone number can take up multiple values. For example, the student can have, say, three different phone numbers. That is represented with a double circle, which means it's a multi-valued attribute. Next, we have stored attribute. Stored attribute is the one that doesn't require any kind of updation. This doesn't require any kind of no change or update. For example, the date of birth of a student. This is going to remain constant and it does not change. Next, that is a stored attribute. Next is we have derived attribute. Derived attribute is the one that can be a derived attribute that can be derived from other attributes is called derived attributes. For example, total and average marks of a student. Say age of an employee, that is derived from a date of birth. So let's consider we have a student. Age can be derived. Say age is derived from, say, from the date of birth. And then also say some marks. So let's assume we have some marks of the student that can be derived from a roll number. So basically, say age, which is derived from the date of birth. This is a derived attribute. We can derive the marks of a student from the roll number. So hence marks is a derived attribute. Next is we have the cardinality ratio. The cardinality ratio is nothing but it describes the number of instances of, say, one entity associated with the number of instances of another entity. So basically, this is nothing but it specifies how many instances of an entity participate in a relationship with instances of another entity. Basically, how is this entity A related to entity B? With how many instances or with what possibilities is this two related? There are three types. Then now you will understand better. You have one to one, one to many, many to one, many to one, and many to many. Now, one to one is an instance where A is associated with at most one instance of entity B. For example, one to one can be defined as C1 entity say you have a in office we have a department. Okay, each department or say a project, it is managed by exactly one employee. It is managed by one employee. Example, every department is managed by one employee. That is one to one. Now, one to many. One to many is an example in which, say, one department has, say, it has multiple employees. So one department can have n number of employees. This is one to many. Now we have many to one, which means that many employees can work under one manager. Example, this is one to one. this is 1 to n, this is many to one, which means that, for example, multiple employees, they can work, say, under a single manager. So this is n to 1. So if we have multiple managers, multiple employees who can report under one manager. This is the example. Many to many is that, let's assume that is n to n. Let's assume we have, say, n number of students, who pick up or who study n number of subjects. So this is n to n. So cardinality ratio is basically, it gives you the relationship as to how how one entity is related to another entity, with how many instances can one entity be related to the instances of another entity. We have four types: one to one, one to many to one, and many to many. And I have given you the examples as well. Next, we have weak entity. What is a weak entity? It is the entity that cannot be uniquely identified by its own attributes. It relies or requires some strong owner, or it requires a stronger entity or another owner entity. So that is a weak entity. So weak entity is the one that cannot be identified on its own, but it requires another strong entity. The weak entity will not have no primary key. It does not have a primary key of its own. Dependence on a strong entity. There is dependency factor. So it depends on a stronger entity. Existence dependency. A weak entity cannot exist. Existence dependency, which means that a weak entity cannot exist without a strong entity. It cannot exist on its own. For example, say we have a weak entity is a double rectangle. It is represented with a double rectangle. Let's assume we have a weak entity called order. Involving an entity order, weak entity is order item. An order entity can have multiple order items. Here, order item may or may not have a unique identifier. It relies on order entity's primary key to identify. For basically, it is a order. Let's assume you have an order and you have an order item or order ID or something. So this is a weak entity because it relies on the order.